Okay, let's go ahead and finish up number 11 on the last page of the 5.6 notes, page 12. So we had totaled up the times, which is what this problem said, the total times. So the rate for the bike was R because it followed than. Walking was 6 less than. So we subtracted 6 from the R. They gave us these. We solved the formula for T. And that told us to fill in the T column, do distance over rate. So distance over rate, distance over rate. And because total means plus, we added and set them equal to 1. Then we took this equation and just turned it into a horizontal equation. We decided right before the last problem that the LCD, everything we see is R and R minus 6. So we had just put that beside every single term. And remember, before we go any further, we do our canceling. So R divided by R, 1. R minus 6 divided by R minus 6, 1. And no canceling there. So now let's write what's left. So we have 6 parentheses R minus 6. We move the coefficient out in front. Plus 1R, and I'll keep that 1 in it because I can see we're going to have some like terms there. Equals, and this one we don't need because we're going to be distributing, so we'll lose it. So 1 times R is just R. So R squared minus 6R. And right away your antenna should go up and you should say, oh, this is a quadratic. We learned about these in chapter 4. Whenever you have a quadratic, power of 2, the equation must be set equal to 0. And we always want to keep the R squared positive. So let's go ahead and distribute, combine like terms, and then we'll bring these over here to keep that R squared positive. So we have 6R minus 36 plus 1R equals R squared minus 6R. So I'm going to turn the equation around because I like having my R squared on the left. So R squared minus 6R equals, and then we have some like terms here. So 7R minus 36. So again, this is a quadratic. Quadratics require, second degree require set equal to 0 so you can figure out your factoring pattern. So everything on this side needs to be brought over by doing the opposite. So subtract 7R, and then I'll go ahead and do this on the same step, plus 36, and then we'll just add that out to the end. So remember, when you bring stuff over, don't forget to do the opposite. Very common mistake by students is they forget to do the opposite when they're crossing the equal sign. So 7R minus 7R is 0. 36 minus 36 is 0. So we definitely have 0 over there, which is our goal. On this side, we have R squared minus 13R. Whoa. Plus 36 equals 0. So, double bubble. We're looking for factors of 36 that add to 13. That'd be 9 and 4. This says the signs will be the same, and this sign says they'll both be negative. So don't forget to do your test. After doing all this work, you don't want to miss the problem because you didn't test it. Negative 9 plus negative 4, negative 13, yes. Negative 9 times negative 4, positive 36, yes. So we have R minus 9 and R minus 4 equals 0. We learned in chapter 4 that usually when you have a quadratic word problem, only one of the answers makes sense. Not always true. We had 1 or 2 that both answers made sense, but be on the lookout. So if A times B equals 0, either A is 0 or B is 0. So we get 9 and 4 as our two possible solutions. R equals 4, R equals 9. So let's put the 9 in. So this is rate. So could he ride a bike at 9 miles per hour? Sure. Then put a 9 in here. 9 minus 6, could he walk at 3 miles per hour? Sure. Okay, let's test the 4. Could he ride at 4 miles per hour? Sure. 4 minus 6, could he walk at negative 2 miles per hour? No. So that one's the one that doesn't make sense. 4 minus 6 would give me a negative walking rate. So then I take my 9 and I put it here and here. And it's asking me for the speed riding and speed walking. So I need to answer these two questions. So let's go up to the top, shall we, to answer the question. So riding, I like to write it like this, at, and then I go, oh, it's just 9, so 9 miles per hour. Walking, at 9 minus 6 equals 3 miles per hour. And there is the answer to my question. Very, very, very similar to the one on your test. The one that I did last night had a total of 1 like this, and it had a bike and then walking. So very similar to your test question. So that's a great one to study. And this is the last problem on your test. This will be number 17. Okay, so let's do the last type of problem. This is probably one of the easier ones. Students love this. The only work behind it is remembering the formula. So anytime you see a work problem, people are painting, people are mowing a yard, people are washing a car. Those are typical ones. Pipes are filling a pool. So anytime you see a work problem, the work formula is 1 over the first person's time plus 1 over the second person's time equals 1 over their time together. And I love this formula because it's so easy to remember. It makes sense that the first person's time plus the second person's time equals their time together. So it makes sense. Why is it over 1? Because it's a rate. If I can do a room in 3 hours, let's say paint a room in 3 hours, my work rate is 1/3. I can do 1/3 of the job in 1 hour. So these are rates, work rates. So if someone can paint in 5 hours, in 1 hour they can do 1/5 of the job. So what you have to be careful with is, when do they give you single people and when do they give you the time together? If they give you the time together, it has to be there. When they give you the single people working alone, they go in these 2 slots. So here's Michael working alone. He can do the room in 5 hours. Delilah, working alone, can do it in 3 hours. So my equation is going to be 1 over 5 plus 1 over 3, and then I can drop the label because there's no t's, so I don't have to, I can just leave it like that. And this is why I love these problems. 1, the formula is super, super easy to remember. 2, they're so easy to solve. So why are they so easy? Because common denominator, 5 and 3 go into 15, and then add a t. So you just put 15t here, 15t here, and 15t here. Multiply your numerators, then divide. Multiply your numerators, then divide. And you'll have a nice, pretty equation with no fractions. So 5 and 3 both go into 15, so the common denominator for them is 15. And then you have to add the t. Remember how you have to write everything you see. I see a 5, I see a 3, I see a t. 5 times 3 times t is 15t. So then we do our canceling. 15t divided by 5 is 3t. Plus 15t divided by 3 is 5t. Here the t's cancel, so I just get 15. Okay, so multiply the top, 15t divided by 5, 3t. 15t divided by 3, 5t. T's cancel 15, and look at that. We're almost done already. Two-step equation. 8t equals 15. Divide by 8, divide by 8. So let's use our calculator. 15 fraction bar 8, and that's 1 7/8 hours. And it should be less than their times together, right? Because this is their time working together. So each of their alone times should be higher. 5's higher, 3's higher, because this is them working alone. This is the other person working alone. This is them working together. So yes, it should be much smaller than that because they're working together. So that makes sense. So if Alex asked you for a sentence or I asked you for a full sentence on a paper pencil test, you would say, working together, they can paint the room in 1 7/8 hours. Nice, huh? Told you they were easy. Woohoo! Okay, so let's go ahead and do the last one. So I can see they're working, so I immediately write the work formula. 1 over the time of the first person plus 1 over the time of the second equals 1 over their time together. So Adele and Adrian wash a car together in 2 hours. So here's my 2. Don't put it over here. These are alone times. So 2 hours working together. Adrian, so we can call this Adrian, working alone, can wash the car in 3 hours. How fast can Adele wash it? So this will be Adele by herself. Okay, so when they give you time together, you put it in the time together, not over here. So I can drop that subscript, so it's going to be 1 over 3 plus 1 over t. I don't need the t sub 2 because now it's the only t in the problem. Okay, so drop that, and then you have equals 1 over 2. So just barely a little bit different than the one before. The one before, they gave you their 2 alone times, and they asked you for their together time. This one, they gave you the together and one of the alones. So now you need to solve for Adele's alone time. So LCD, write everything you see. I see a 3. I see a 2. I see a T. So the LCD is 6T. So in the numerator of every fraction, do 6t times 6t times 6t times. Almost there. So now multiply the numerators, then divide. 6t divided by 3 is 2t. Here the t's cancel, so I just get 6 equals 6t divided by 2 is 3t. So I need all my t's on the same side, so I'm going to break my little rule and bring them to the right since that 3t's already over there. And I get 6 equals 1t, which is t, so that means t equals 6, and I see it's hours. So this is Adele's time working alone. So if I had to write a full sentence, I would say Adele can wash the car in 6 hours. So Adrian can do it alone in 3 hours, working together 2 hours, but Adele alone would be 6 hours. So really, really nice, easy problems. I love the work problems. They're the best. Okay, that's the end of chapter 5. Now it's time for you to study. Don't forget to do the electronic practice test in Alex before you take your test.